Welcome back to the deep dive, where we take these complex tech blueprints and try to turn them into your personal mastery checklist.
Mm.
If you've ever looked at a complex AI architecture diagram and just felt, completely lost, you are definitely in the right place.
Yeah, it can feel like you're trying to read another language sometimes.
Exactly. So our mission today is really hyper-focused. We are taking those knowledge gaps, those topics where you realized you needed a deeper understanding, maybe because you missed a few key questions on a practice exam, and we're going to turn them into a complete checklist.
That's the goal. And it's not just about reciting definitions, right? It's about getting the design philosophy, the real context behind why certain components are chosen over others within the Salesforce AI architecture.
Right.
If you're going to be implementing Agentforce or Data Cloud or Prompt Builder,
Mm.
you have to grasp the nuances. Things like dynamic integration, robust data grounding, and of course, configuration security. I mean, that's what makes for a reliable deployment.
Okay, let's unpack this. We've sort of organized our material into three major pillars that I think really define success or failure. First, we're going to tackle the AI communication layer, all about the protocols and actions that govern how the agent behaves. Second, we'll get into building trust. This is all about the data grounding, retrieval, and the security policies that protect it.
Foundation.
And finally, we'll analyze prompt engineering best practices and, the nitty-gritty of workflow integration. This is going to be dense, so let's just jump right in and master that first core area, how these agents actually decide what to do.
Let's do it. We can start with the mechanism that gives the agent its dynamism. I mean, anyone can build a static chatbot. A truly intelligent agent, though, needs to adapt. It needs to dynamically select its tools.
And then that's the core question that I find so fascinating. How does an AI agent, which is, at its heart a large language model, how does it dynamically choose the right external service or API to call at runtime, all based on some vague request from a user? This dynamic capability, that's all powered by the Model Context Protocol, or MCP. And this is where it gets really interesting.
It really is. MCP is, you could argue, the most foundational piece of the entire Agentforce puzzle. It's an open protocol, but it's completely integrated and standardized inside the Salesforce ecosystem.
Okay.
Its core function is to let agents or models dynamically discover, select, and then invoke APIs or other tools in real time based on what the user actually needs. It sort of abstracts away all the messy details of the APIs and just presents a standard set of capabilities to the model.
But hold on, if MuleSoft is the gold standard for integration, why can't we just, define the 10 available endpoints statically in the agent's instructions and just let it pick from that list? Why do we need a whole new protocol like MCP for this?
That's a fantastic question, and it really gets to the heart of static orchestration versus dynamic discovery. So MuleSoft is amazing for exposing APIs securely, no doubt. But if you integrate it statically, the agent's decision-making is, well, it's limited to what you explicitly programmed it to call. It has no flexibility at runtime.
It's rigid.
Exactly.
Yeah.
MCP solves this by creating a standard communication layer where capabilities are described semantically. So when a user asks for something complex, like analyze my Q3 returns and suggest a remediation plan, the agent queries the MCP server, which dynamically spits back these capability descriptions. Things like API for financial analysis or tool for legal compliance check. The LLM then reasons over those descriptions and picks the best one, or maybe orchestrates two different ones that it didn't even know existed a second ago.
Wow. So the agent isn't just following a static recipe book. It's more like a chef choosing the best knives and pans from a huge dynamic kitchen based on what it needs to cook right now.
That's a great analogy, yeah. And that flexibility is what makes it a true AI agent. Now, let's compare that to the agent-to-agent protocol, or A2A. People sometimes get that one confused with MCP.
I can see why. I mean, A2A sounds like it's for communication. What's the specific boundary there?
So A2A is purely for communication and coordination between different AI agents. You might have a customer service agent that needs to collaborate with a specialized inventory agent to fulfill a request. A2A is that inter-agent dialogue protocol.
Okay, so it's agent to agent, literally.
Literally. It has absolutely no function in dynamically selecting or invoking external API services or tools. That job API discovery and invocation, that is the sole domain of MCP.
That clarifies it perfectly. The key takeaway is that MCP allows dynamic integration of new services on the fly. That's a huge deal.
It is.
So let's drill down from the protocol to the actions themselves. I know this is a point of confusion for a lot of people. What component is it that primarily guides the Agentforce reasoning engine on when and how to use a specific custom action?
That responsibility falls squarely 100% on the instructions.
Instructions.
Yeah, the instructions are those comprehensive, natural language directives you give to the reasoning engine. You can think of them as a detailed prompt for the LLM. They are the rulebook. They dictate the execution behavior, the inputs it needs, the whole logic of the custom action.
So the instructions define the how. And the other options you might see, like action triggers or output types, they're just handling different parts of the process. Triggers just kick things off.
Precisely. An action trigger determines when an action might be invoked, based on a keyword or some context. But the reasoning engine is looking at the detailed instructions for the actual execution plan.
And output types.
Output types just define the format of the result. Is it JSON? Is it natural language? It has no influence on the logic itself.
This brings us to a really practical point about writing those instructions, including example user messages. Why are those examples so critical for getting the intent accuracy right?
This is all about mitigating the LLM's natural tendency to generalize too broadly. If you just write, this action handles order modifications, the model might trigger it if a user asks something like, when did I order this? Which is totally wrong.
Right. That's a query, not a modification.
Exactly. So you have to include explicit examples. Things like, I need to change the shipping address, or can I update my product selection? These examples provide essential in-context learning. They help the model map all that variable user phrasing, slang or synonyms to the one single correct action. It dramatically enhances grounding and reduces false triggers.
And reducing false triggers is huge. I mean, that's about maintaining user trust and not wasting operational cycles.
Absolutely critical.
Let's troubleshoot a scenario, because this is where the theory meets reality. Say the agent correctly identifies the topic as service requests, but then it executes the wrong action. It tries to process a cancellation instead of just checking the service history. Where do you look first?
Yeah, that's a classic one. If the topic is right, the fault is almost always in the action instructions for those two competing actions.
Okay, so the instructions are probably too similar.
Exactly. It's a signal that the instructions for the cancellation action are either too vague, maybe too broad, or they just overlap too much with the instructions for the service history check. The LLM is literally struggling to tell them apart semantically. You have to go back in, use clearer language, and add more explicit differentiating examples to sharpen the model's focus.
That makes perfect sense. It clarifies the role of instructions versus the topic. Okay, what about standard actions? If a manager asks the agent, show me all customers in New York with an overdue balance over $5,000, what standard action is Agentforce likely using under the hood?
That's a retrieval of a filtered list based on multiple criteria. The standard action for that in Agentforce is query records.
Query records.
Yep, that action is specifically designed to fetch a list of records that match whatever dynamic filter conditions you give it from the Salesforce data model.
And why not something that sounds similar, like select records or fetch records? I could see those tripping someone up.
Yeah, the naming is subtle. Select records is usually for scenarios where you're choosing a single record or maybe presenting a manual selection list to the user. It's not for dynamic filtered mass retrieval. Query records is the specific term you need to know for that criteria-based lookup function.
Got it. Okay, before we move on to data grounding, let's just touch on one more critical constraint: token limits. This is a physical reality that impacts absolutely everything we retrieve.
It is the ultimate constraint. Every piece of context, the user's query, the instructions for the action, all the grounding data you pull from CRM or Data Cloud, it all gets bundled together and sent to the LLM. You have to constantly be aware of the size of that bundle.
Because if the grounding data, say 10 huge case records, makes the whole input exceed the model's token limit,
Then the execution will fail, or at best, it'll degrade.
and when it degrades, what's the risk there? What actually happens?
The risk is pretty substantial. The AI might truncate the data, which means it just chops off the end of a long document. Maybe the most important, concluding information is lost, leading to an incomplete or just plain wrong response.
Or it just fails entirely.
Or worse, the LLM just fails to generate a response at all. And from the user's perspective, that's a system error. And since you're paying per token, managing this volume isn't just a performance issue. It's a cost constraint.
That is the perfect segue. An agent is only as reliable as the data it can access. Let's move to our second pillar, the data foundation, and just as importantly, its security.
Yes, and if we connect this to the bigger picture,
Hmm.
the whole shift from a generalized LLM to an effective enterprise AI agent, it all hinges on data grounding. It's about accessing information securely, accurately, and whenever you can, deterministically. The agent is only as good as the internal authorized data it can get its hands on.
So let's talk about the architecture for that. If a company, say Universal Containers, wants their agent to reason over past resolved cases, we're talking unstructured text, right? Detailed case descriptions, internal comments, long resolution notes.
A ton of text.
Exactly. What kind of object structure in Data Cloud is required to handle that?
To handle that volume of complex, unstructured text, and more importantly, to let the agent reason over the meaning of it, not just keywords, they need to be using unstructured data model objects, or UDMOs, in Data Cloud.
Okay, UDMOs. Why is that choice UDMOs over standard DMOs so foundational? It feels like a subtle distinction, but I'm guessing it's a critical one.
It is probably the single most important architectural choice you can make for effective AI grounding with text. DMOs, the standard data model objects, they're optimized for structured data, IDs, numbers, rigid fields.
Right.
UDMOs, on the other hand, are specifically designed to ingest, normalize, and process text-heavy, unstructured data. We're talking long-form documents, case summaries, chat transcripts, you name it.
And the key capability that UDMOs unlock is?
They enable you to create semantic search indexes. When you use a UDMO, the text gets converted into these high-dimensional vector embeddings. This is what allows the AI agent to find similar cases based on the underlying meaning of the user's query, even if the keywords don't match at all.
So you're moving beyond just string matching.
Way beyond. If you try to stuff complex text into a structured DMO, you just lose all that semantic power. You're stuck with old-school, less effective keyword matching.
So if a user asks, my dishwasher is making a weird buzzing noise after the rinse cycle, a semantic search built on UDMOs could match that to a previous case titled vibrating appliance after water drainage, even though the words are completely different.
Precisely. It's matching concept to concept. And that's absolutely essential for effective knowledge retrieval and finding historical context.
Okay, so we've got our data structured correctly in UDMOs. Now let's talk retrieval efficiency. If the default retrievers are too broad, maybe they're returning too much data and we're hitting those token limits, why would an administrator create an individual retriever?
You'd create an individual retriever when you need that fine-grained, precise control over the exact data payload that gets sent to the agent.
Yeah.
They let you define 3 critical things that default retrievers don't.
And those are?
1, you can select the specific fields you want to include, which is huge for reducing the token count. 2, you can apply very specific filters or pre-filters to limit which records are retrieved in the first place. And 3, you can control the exact number of results returned, like, give me the top 3 hits only.
That level of control seems necessary for both performance and security. Let's dig into the security angle with that example we were talking about, ensuring only active warranties are used. If we just rely on the Agentforce instructions, that filtering is, what, probabilistic?
It's totally probabilistic. The agent might still pull 10 warranty records, some active, some not. The LLM, based on your instruction, only use active warranties, is just going to try to filter the data it receives. It might even waste tokens explaining why it can't use the inactive ones. It's inefficient, and it's risky if the model misunderstands the rule.
So it's not a guarantee. How do we get that deterministic result? How do we guarantee that warranty status equals active every single time, no exceptions?
The required architecture for that is a combination of hybrid search and custom retrievers using pre-filters.
Okay, break that down.
Hybrid search gives you excellent retrieval accuracy by mixing keyword and semantic search. But the real key here is the custom retriever.
Yeah.
By applying a pre-filter at the data source level, literally warranty status active, you are enforcing deterministic retrieval. Only the active records are ever even pulled from the database to be sent to the LLM.
Ah, so you're filtering before the AI even sees the data.
Exactly. It guarantees security, it reduces token usage, and it ensures accuracy before the probabilistic model even gets involved.
Okay, let's talk about messy user input. We know customers are going to misspell things. If a customer frequently misspells a package name, and we know keyword search will fail them, what's the most effective way to handle that?
This is a textbook case for vector search, because vector search uses those semantic embeddings we talked about. It matches the meaning and the conceptual similarity of the query. So if the user types Platinium package, the vector search recognizes that the embedding for that misspelling is incredibly close in vector space to the correct platinum package, and it makes the match. It basically self-corrects based on conceptual understanding.
Whereas keyword search would just see platinum as a totally different, non-existent word.
Absolutely. Vector search is really the essential tool for handling the natural messiness and ambiguity of human language.
Okay, and what about large documents? When we're chunking, say, a big HTML knowledge article, why is section-aware chunking so much better than just breaking it into, like, 500-word chunks?
Because arbitrary chunking just destroys the logical structure of the document. Imagine you split a section called Step 4, Troubleshooting, right in the middle. The resulting chunk of text loses all its context.
It's meaningless on its own.
Exactly. Section-aware chunking respects the document's inherent structure, the headings, the subsections, the HTML tags, to break the content into logical contextual units. It preserves the hierarchy, which makes retrieval far more accurate because the AI always gets a complete, coherent piece of information.
That makes a lot of sense. All right, let's pivot to the absolute foundation of trust, security and compliance. We have to be really clear on the zero data retention, or ZDR, policy. What are its three non-negotiable tenets?
ZDR is the cornerstone. It's what allows enterprises to even use this technology. It guarantees three things. First, your customer data is not used for LLM training by the provider or by Salesforce, period.
Okay, number one.
Second, any data used for grounding is not retained outside your customer Salesforce org after that interaction is over. It's ephemeral. And third, the grounding data cannot be accessed by the LLM provider's employees. That complete isolation is non-negotiable for compliance.
And dynamic grounding is the process that actually enforces ZDR during a live conversation.
Correct. Dynamic grounding is the mechanism that ensures only relevant and, importantly, authorized Salesforce data is securely retrieved, used for a moment to inform the AI's response, and then immediately released. It maintains security and keeps the AI up to date without that retention risk.
And one last security point. If a company wants to use their own fine-tuned LLMs but integrate them securely into Salesforce, what's the approved path for that?
The only secure approved pathway is through Einstein's Studio Model Builder.
Why that specifically?
Because that framework lets you integrate your models while still leveraging the full Salesforce trust layer. It keeps everything within the defined security and compliance environment. If you try to use less secure methods like, external callouts or embedding in an iframe, you're bypassing all those critical security and auditing layers. It's a huge risk.
The message is clear. Trust is built at the data layer, it's secured by ZDR, and it's maintained through deterministic retrieval. Okay, let's move to where this data actually meets the language model in Prompt Builder. So let's talk about the sharp end of the spear Prompt Builder. What stands out to you about optimizing these templates? It's not just about writing a good sentence, it's about knowing the operational constraints of each template type, right?
Absolutely. You have to pick the right tool for the job. Selecting the wrong template type for your task or where it needs to run. That's a direct path to either operational failure or just zero adoption.
Okay, let's run through some use cases. If a marketing team needs to generate a detailed, cohesive product description by pulling together, say, 5 different fields from a single product record name, price, features, status, which template is the best choice?
That is the perfect use case for the record summary prompt template. It's specialized for exactly that, aggregating multiple structured data points from one single record and weaving them into a coherent narrative. It's perfect for generating consistent marketing copy.
And how is that different from the field generation template? They sound kind of similar.
Field generation is designed for a much narrower purpose, automatically suggesting or generating a value for a specific single target field.
Ah, okay.
Think about generating a 3-sentence summary to populate a large description text area. And the crucial detail is how it's implemented. It has to be associated directly with the target form field on a Lightning record page. It's a UI helper for an end user, not a tool for back-end automation.
That distinction, UI helper versus general automation, that's critical. Now, what if we need maximum flexibility? What if we need to pull data from 5 different, completely unrelated objects, like an account, a custom project object, and maybe some web activity logs all into one prompt?
For that kind of complex data fusion, you need the Flex template. The Flex template is the most adaptable one. It's specifically designed to accept inputs from multiple, often unrelated, standard and custom objects directly into the prompt. It's what you'd use for generating, say, a complex proposal that needs data from all over the place.
So at the end of the day, Prompt Builder is all about creating dynamic, context-aware text.
Precisely. It takes that secure, structured CRM data and gives the language model the factual grounding it needs to generate coherent, useful narratives,
Right.
whether that's drafting a newsletter or replying to an email.
All right, let's get into the weeds on the technical constraints. This is where I know people can get stuck. What's the key limitation when you're trying to merge related list fields into a prompt builder template?
The big one, the one that always comes up, is polymorphic fields.
I remember this one, but can you explain why they fail? What's happening technically?
It comes down to schema ambiguity. A related list that uses a polymorphic field, think of the who'd or what'd on activities, which could point to a user or a lead or a contact ed, the system can't reliably merge it.
Because it doesn't know what kind of object it's going to get.
Exactly. The template parser has no idea what object schema to expect when it's preparing the data. And since it can't guarantee the field types, it just rejects the merge for safety and reliability. Standard related lists where the child object type is fixed and known are fully supported.
That's a major operational constraint to be aware of during design. Okay, let's talk about integrating Data Cloud. If Data Cloud enriches a contact record with their recent web activity, how does a contact prompt template actually pull that activity data in?
It's a structured process. First, Data Cloud has to enrich the contact record itself, making that web activity available as a standard, fixed schema related list that's linked to the contact.
So it has to be a proper related list on the page layout.
Yes. Then, the prompt template uses related list grounding to dynamically pull the context from that specific list. The template isn't talking directly to the raw Data Cloud data lake. It's interacting with that enriched related list right there on the contact record.
Got it. Okay, let's talk prompt structure. If we're giving the LLM some non-negotiable instructions inside the template, things like limit the response to 3 sentences and use only positive language, what's the best practice for making sure the AI understands those are rules?
The standard highly recommended practice is to surround those instructions with triple quotes.
Like 3 double quote marks.
Yes, exactly. It acts as a clear delimiter. It basically tells the AI model, hey, everything inside here is a meta instruction or a guardrail. Follow it strictly, but do not mistake this for the main content you're supposed to be generating. It vastly improves the AI's compliance with your directives.
That's a great practical tip. Okay, workflow integration. If I'm in a flow and I calculate some dynamic value, like a customer loyalty score, and I need to pass that variable into a flex prompt template, what's the specific flow element I use to do that?
The precise element you're looking for in the flow is called add prompt instructions.
Add prompt instructions.
That's the one. That element takes your dynamic variables from the flow, like that loyalty score formats them, and injects them directly into the prompt template's context for grounding.
Perfect. And one last troubleshooting question. This one's for the admins. If you're building a flex prompt template and the preview button is grayed out, what's gone wrong?
The issue is a lack of context. Flex templates are complex. They need real grounding data to simulate a generation. If that button is inactive, it means the administrator has to manually select the specific related records, the account, the contact, the opportunity, whatever the template is grounded on, to provide that context.
So you have to feed it the example records first.
You have to. Without that mandatory contextual data, the system can't execute the generation, so it can't show you a preview. Context is everything. AI generation isn't magic. It's absolutely bound to the specific data context you provide.
Okay, that makes total sense. We've covered the agent's logic, its data foundation, and how to prompt it. Now let's talk about putting it all into production.
Yes, knowledge is most valuable when it's applied. So now let's look at the operational side, how we deploy, secure, and monitor these sophisticated tools.
Let's start with the agent's identity and its permissions. When you deploy an Agentforce service agent, a special user gets automatically provisioned. What is that permission set group it gets, and what's the best practice for giving it access to, say, a new custom object?
That special user is assigned the Agentforce Service Agent User PG. It's a bit of a mouthful.
It is.
That's the Managed Permission Set group, defining the agent's base access. And the best practice for extending its permissions is to extend the access within that existing PSG. You modify the PSG itself to include the new permissions. This keeps all the agents' access consolidated, auditable, and aligned with the security framework.
It keeps things clean. Okay, now for a really critical security implication, execution mode. When a custom agent action invokes a flow, in what mode does Agentforce run that flow by default?
It executes the flow in system mode.
And what is the massive implication of that, especially for security?
System mode means the flow runs with elevated permissions. It runs with full system access, completely ignoring the permissions of the end user who started the conversation.
So it bypasses the running user's field-level security and their sharing rules.
It bypasses everything.
Why? Why would Agentforce mandate that? It sounds risky.
It is risky, but it's for deterministic reliability. Think about it. If the flow ran in user mode, the agent's ability to complete an action would depend on who's asking. If a user didn't have permission to see a critical inventory field, the flow would fail, and the agent couldn't do its job.
So it's a trade-off.
It's a trade-off. By using system mode, the action succeeds reliably every single time. It guarantees the agent has consistent access to the data it needs to perform its business function.
But that means the responsibility for security shifts entirely to the developer. The person designing the flow has to make sure their logic doesn't accidentally retrieve or expose data the end user shouldn't see.
100%. The developer is now the security gatekeeper.
So what's the countermeasure here? How do you manage that risk?
The countermeasure has to be stringent auditing and incredibly careful flow design. You need a robust monitoring strategy, probably using event monitoring or some custom audit logging, to track exactly which system mode flows are run and what data they touch. The developer has to ensure the flow only retrieves the absolute minimum required data and is designed to enforce security with its own logic, since FLS is gone.
Okay, let's talk deployment lifecycle. We've built our complex flows in a sandbox. We deploy them to production with a change set. But then the agent fails to invoke the flow in production. What's the most likely and easily missed cause?
The classic deployment, gotcha. Flow activation.
It's not active.
It's not active. The change set successfully moves the flow metadata, but flows are not automatically activated in the production environment. They just sit there in an inactive state.
So the fix is just a mandatory manual step after every deployment.
Precisely. The administrator has to log into production and manually activate the flow. If it stays inactive, any attempt by the agent to call it is just going to result in an immediate failure.
Got it. Okay, so the agent is live. We need to monitor its performance and its cost. Let's clearly distinguish between the two main monitoring tools. Where do we go to track credit consumption for all these AI interactions?
All cost tracking, credit usage, that's managed by the digital wallet. That's your financial dashboard. It gives you the breakdown of credits consumed by agent, by session, by feature. It's what the finance teams use to monitor the budget.
And if I need to see how effective the agent is, its adoption rate, its success rate, its performance.
For all performance metrics, usage stats, and adoption dashboards, you use Agentforce Analytics. That's the tool that gives you the business intelligence to actually measure the agent's effectiveness and drive adoption.
Perfect. And finally, let's just make sure we understand the data hierarchy for logging. This is crucial for auditing. What's the correct three-tiered structure for agent activity logs?
The logs are structured from the macro level down to the micro. At the top, you have agent session. That's the overarching container, the entire conversation thread.
Okay, the whole chat.
The whole chat. Then inside that, you have agent interaction. That's a single question and answer exchange within the session.
One turn.
One turn. And at the most granular level, you have agent interaction message. That represents a single piece of communication, either the user's input message or the AI's generated output message.
A session interaction message. Got it. Okay, last operational step. Connecting the agent to a channel. Let's say we want to connect our Agentforce service agent to a digital experience site that's using messaging for in-app and web. How do those inbound messages have to be routed?
Right, so regardless of whether the final destination is a human agent or our AI agent, all inbound messages from that channel must be routed through omnichannel flows.
Why is that flow a mandatory piece of the puzzle?
The omnichannel flow is the essential processing and routing layer. It's what receives the message, first of all. Then it allows you to do necessary enrichment, like pulling in pre-chat variables, maybe a membership number from the user's profile. And then, based on your logic, it directs that work item to the correct destination, which in this case is our configured Agentforce AI agent.
Wow. Okay. We just covered a phenomenal amount of ground. We went from the dynamic service discovery of MCP through why you have to use UDMOs for semantic grounding, all the way down to the nitty-gritty of individual retrievers and prompt builder limitations, like no polymorphic fields. I feel like we've successfully turned those areas of confusion into solid architectural understanding.
I think the key takeaway here, if you look at it from a high level, is structural. All of these components, the prompt builder templates, the agent actions, the retrieval methods, they're all meticulously designed to shift the AI from generic probabilistic guessing to deterministic trustworthy grounding. It's all based on your secure, structured company data.
It's about shifting from maybe to definitely.
That's the entire game. That shift is the core principle behind reliable enterprise AI.
And it seems like the difference between a successful implementation and a failed one is really understanding those constraints. Knowing that instructions need explicit examples, that flow activation is a manual step, and that system mode is an explicit bypass of sharing rules for the sake of reliability.
And that actually raises a really important question that you should be thinking about as you design your own architecture.
Okay.
If Agentforce relies so heavily on the Agentforce Service Agent User PSG and system-level flow execution to guarantee reliability, and in doing so it deliberately bypasses standard security controls, what layers of auditability, things like event monitoring and custom logging, become your ultimate security guardrails?
Right.
When operational reliability forces a security bypass, understanding the risks and planning for the monitoring becomes the single most critical task for any developer or architect. You have to ask, what audit frequency or data visibility will you mandate to be able to sleep soundly, knowing your system mode flows are properly protected?
That's a deep dive into the intersection of power and governance, and it's a perfect place to wrap up our session. Thank you for joining us on the deep dive. We really hope this mastery checklist helps you implement your next AI solution with total confidence.
Absolutely. My pleasure. See you next time.